WMPG thrives with support from listeners and from Maine Solar Solutions. Maine Solar Solutions, helping empower homeowners and businesses with solar electric solutions for 9 years. Information at mainsolarsolutions.com.
You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me, as always, is Bernie Rhyme, DJ Starwatcher. How are you, Bernie?
Yes, hi Sarah, very good, thank you.
Bernie's our professor of the Astronomy Lab here at USM and our local protector of the night skies. Reach out to us at WMPGScientificallySpeaking@gmail.com or on Twitter at WMPGSciSpeak. And you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, could you let our listeners know what is up in the night sky for this coming week?
Yes, certainly. So we have a good week coming up. This will be Friday, May 27th. So the planets are starting to line up really nicely for the big conjunctions happening starting early next month. So we'll get a lot more into that. But the days, of course, are getting longer. It's almost summer. The sun comes up at 5:05 in the morning and doesn't set till 8:10 in the evening. So over 15 hours and 5 minutes for the sunrise. The moon will be almost new. It'll be a waning crescent moon coming up about 3:30 in the morning or so. So it'll be new on the 30th. So then the planets in the morning sky, starting with Saturn. Saturn now comes up around by 1 in the morning already. And then Mars and Jupiter come up a little bit later. They'll be really close together, like only a degree or so. And then you have to go a few more, maybe another 10 or 15 degrees, and then you'll see Venus. You get Saturn, Mars, Jupiter, and then Venus. And soon, in another week or so, Mercury's going to join them, and they're going to move around a little bit to be in order from Mercury out all the way out through Saturn. So that'll be really interesting. And if you have binoculars or telescope, even Uranus and Neptune will be in that lineup and not in sequence. But so we'll talk more. But just start looking at them now, and where they're juggling kind of in place, almost like a horse race, to get ready to line up perfectly for the big happenings for next month. So you can see those 4 in the morning sky. Days are getting quite a bit longer. Of course, we couldn't see that lunar eclipse last time. I was able to watch it online, and really, really nice eclipse. And there's another on November 8th, the total lunar, that everybody in this area can see. So kind of get ready for that. Hopefully it'll be clear on November 8th.
Yeah, hopefully. I did post a lot of memes about what the weather does when we want to observe a fantastic astronomical event.
Yeah.
And yeah, it's always rainy or cloudy here in Maine.
So people buy a new telescope or a new camera. That always happens at our club too. Yeah.
Awesome. Well, thank you, Bernie.
Yep, you're welcome.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. So welcome to another episode of Scientifically Speaking here on WMPG. And we are joined with this very interesting setup right here with our special guest, Dylan Hoy, who is our music producer for the show, an avid moviegoer, and he's a huge fan of the show, right?
Yes, indeed. Yes, indeed.
And actually, he often raises questions that do prompt very interesting shows, such as the show we did on understanding where fossil fuels came from. So that was a couple months ago, I believe. And so, as always, Dylan is always bringing up questions related to science that I'm like, I'm not totally sure if I know the answer to that, but Bernie, what do you think about doing a show on this? And so, it's a way for us to explore and learn more about science and share that information with our audience. So, Dylan.
Yes.
I formally welcome you to the show.
Thank you.
And you are a huge fan of movies.
I am. That is an accurate statement.
Recently, there has been, multiverse movies. I'm just going to say it out there.
Yes.
That's what we're kind of talking about. Or movies that use the multiverse as a storytelling tool. There have been many, I think, in the past. I can't really think of any right now. I feel like The Matrix is one. But would you consider that like a multiverse? Kind of.
Simulation? I think that's more simulation.
Okay.
But
But recently there have been two big
I
movies.
think there's two that I'd like to kind of give you guys some more information on today.
Okay, so what prompted our show were these two movies that have been hugely successful and have used the multiverse as kind of the crux of that show, or the movie, sorry, the crux of the story of that movie. So why don't you go ahead and tell us a little bit about those movies and how they use the tool to tell the story,
Yeah.
and a little bit about what's different between them.
So the two movies that I'm gonna kind of give you guys some brief information are Spider-Man: No Way Home and Everything Everywhere All at Once. And I guess I'll start with my favorite, Spider-Man: No Way Home. So basically, in that, Peter Parker. Not to go into spoiler territory in case anyone hasn't seen the movie.
You're fine.
So there was like a big thing that happened at the end of the second movie that leads into Nowhere Home, and so that mistake kind of spreads into Peter Parker's life, and so it's affecting his friends and his family, and so he wants to, kind of fix that because it's not necessarily their fault, right? So he goes to meet Doctor Strange, because he's a spellcaster and he can kind of help fix the situation. So he's like, "Hey, can you, cast a spell to make everyone forget who I am so it doesn't affect these people in my life?" And while they're doing the spell, he's like, "Oh man, I don't want this person to forget. I don't want that person to forget." And so in that process, he's actually messing up the spell. And it gets to a point where the spell just becomes radioactive in a way and shatters the fabric of, I wouldn't say space time, but just reality, which allows other multiverses to kind of seep in to the world that Peter Parker's in. And so this kind of lets enemies that he's fought in the past from different universes come in. And so he has to capture them, bring them back so they can kind of send them back to their worlds and fix everything. So that's kind of like the story plot in that movie. In Everything Everywhere All at Once, it's completely different. So the main character, I'm forgetting her name, Evelyn. She runs a laundromat with her family, and they're kind of having troubles in terms of like IRS. I think they're being audited. And so they go to kind of talk to this person at the IRS to kind of fix things.
Yeah.
And all of a sudden there's a situation that kind of pulls her into the multiverse, but it's displayed completely different. It's more about connecting to your alternative selves in like the different universes, but it first manifests in her husband. He's reaching out to her from a different version of himself in a different universe, saying, "Hey, we gotta save all the multiverses because there's this big baddie that's trying to take over." And so to do that, it's kind of crazy, but it looks like Bluetooth ear like phones. There's two of them, and in this you have to do something completely bizarre that goes against like the nature of things in your world, I guess. And so an example of this is during one of the scenes, she's fighting someone who's like taken up one of their personalities from a different multiverse, so she can be like a wrestler. But Evelyn, she decides to snort a fly, and then she can access another version of herself in the multiverse to be able to fight back. And just it's like different versions of that to kind of progress the story in that movie.
Okay, so Bernie, do you hear the two differences? So in the Spider-Man Marvel universe, it's kind of like the portals have been opened, and all these creatures, characters, other people are now kind of infiltrating one particular reality. Whereas in Everything Everywhere All at Once, you are trying to create, it's not really portals, but you are trying
a connection.
To access.
It's like a connection.
And what is also different is that in the Marvel world, the only way that they seem to show like a parallel universe is really through just the Spider-Man character themselves. Everything else is different. Whereas, something about this, right? In Spider-Man No Way Home, you have the 3 Peter Parkers, but they're not the same Peter Parker. They just happen to be Spider-Man, and they all happen to be named Peter Parker, but they don't look the same, even though they have the same kind of family.
And background of
Right.
how they became
Right.
Spider-Man.
Whereas in Everything Everywhere All at Once, it's the same person. You look the same, but you just have gone a different life path somewhere else. Does that sound about accurate?
Yes. Yes,
Okay.
yes, yes.
So in thinking about those, we wanted to do a show that kind of explores multiverse theories or hypotheses, interpretations of some of them. And let's start with Bernie. Why don't you start with is it Max Tegmark?
Yeah, Max Tegmark, yeah.
He wrote a book called Our Mathematical Universe,
Yeah.
and it tries to kind of grapple with this multiverse scenario. And he basically breaks it down into 4 levels of multiverse.
Yeah. That's the scientific part. He's a Swedish physicist that teaches at MIT and he's written a bunch of other books. So he's really good with all this and he's a good explainer. I've seen him on Neil deGrasse Tyson and different places, so he's really good. All right, so there's 4 levels. So the first multiverse would basically be our own universe, just expanding into more of the same. Because of the limited speed of light, we can only measure the diameter of our universe at about 100 billion light years. I mean, that's pretty big. It's way bigger than it is old. It's only 13.8 billion years old. It's almost like going up the down escalator. The way the light comes back to you as it's expanding, that's why it's so much bigger. Okay, but it could be 100 trillion. It could even be infinite. Just stars and galaxies and things like we know about. So that would be the first.
So how is that a multiverse then?
Well, it will be infinite because it's there's other multiverses to get more interesting, but it's multiverse because we can never see outside of that. It's almost like in a sense we're in a black hole because we have that event horizon that just based on the speed of light we can't see beyond. People always ask me what is the universe expanding into, and just more of the same.
Good question.
Yeah, I mean unless we get into some of the other more interesting universes. So the second one is like bubble universes. Each universe we don't know the exact shape, but if it's circular like a big sphere and it just keeps expanding, then there could be an infinite number of those, or even a limited huge number of them. And then each universe, in that case, could have all different laws of physics, which would be really interesting. It's not just expanding into more of the same. It has all different laws of physics. Some could have life as we know it. Some could have other life. And it could be, I mean, some have a set number and some have an infinite number of these bubbles. And they can interact. They can touch through something called a membrane, or a brain for short. And that's where some of string theory gets in. And that, we're kind of looking for maybe some of those signs within our own universe, which we haven't really found yet or proven per se. And then the third one is probably one that.
Before you go on to that, so
yeah.
Is that saying that each universe is a bubble?
And yeah, it started at its own Big Bang. In this case, the laws of physics are still the same, but in one of them, but they could be different in other ones. But they could have started at some Big Bang, or they could have their own different starting times also. They get more interesting. There's more and more possibilities, and dimensions keep adding up to when you get into some of those. Some of those levels also relate to other dimensions.
Gotcha.
And then the third one is probably what a lot of people think of, the many world interpretation of quantum mechanics, the parallel universes. So in essence, any decision you make will create something slightly different, and all those possibilities have happened. And so, I mean, there's different ways to interpret that. But if you have like all these other parallel universes, maybe a little bit more like what Spider-Man is based on, the other characters coming back kind of in this one, that opens a lot of those possibilities. It's just an interpretation. I mean, most people don't go with a standard Copenhagen interpretation anymore. That's just the wave function collapse. It really doesn't tell you. It's not as many open to possibilities as parallel universes in many worlds. That was actually just back in 1957, that someone named Hugh Everett came up with that, the splitting the possibilities. So all the things are kind of possible at once that way too. So that would kind of work for Spider-Man. And then the fourth one is the most complex. That would be like nested Russian dolls. I mean, there could be a universe within a universe. And that's something when I remember just talking to some people, that's kind of what they would think of first. And then each universe, almost like the Mandelbrot set, we could be at any point in that set, and it just repeats in very intricate, beautiful artistic patterns, and then they go up and down in all levels. And every one of those would be nested universes with different big bangs. There's something called eternal inflation, different starting points, different laws of physics. That's the most complex, interesting. It's an infinite space called de Sitter space, and and then you can get up to 11 dimensions. Pretty much anything the mind can think of, kind of at those levels. Because obviously we can't prove any of them, not even the first one, because
Yeah.
we have a limited light cone. But we can think of all the others, and there's some actual math. I mean, that person named Michio Kaku, who's a string theorist, he said 13 dimensions will be unstable. You cannot
Mhm.
build universes in 13 dimensions. We just did a show on superstitions because that's actually unstable and will collapse. So string theory is based on 11 actual mathematical dimensions, which is really interesting. I don't know how we can prove that, but he can, in some sense, actually prove that. So
Interesting.
that's interesting too.
So your level 4, when you're talking about, that's like the nesting dolls. Um, am I getting it wrong that it almost sounds like you would be able to observe all of those then?
Well, in a sense, I mean, another way to look at it is that at every point, our 3D universe, well, including time, would actually touch a point within any of the higher dimensions. We can just go one dimension up. And the other dimensions are curled up, like inside the electron. They're that
Mhm.
small, we just can't observe them. So in some sense, yeah, it's almost like your second movie, everything all at once. It is all possible right here in this second, no matter where anyone happened to be in physical space, really doesn't even matter.
Mhm.
It's all here at once. We just have no way to, our perceptions don't access them, but there are ways to access them.
Okay, Bernie seems to relate level 3 with the Spider-Man
Hmm.
one, and then level 4 with possibly the Everything Everywhere
Mhm.
All at Once. I mean, it almost sounds like a mix.
Yeah.
Um, do either of those, do any of those concepts or those 4 levels seem to be what those movies are trying to depict?
I'd say what Bernie was describing for at least the Spider-Man one makes the most sense
Mm.
to me. Um, I mean, I feel like the fourth one, I'd have to really delve into it a little more to kind of grasp how it connects to
Mhm.
to everything everywhere all at once. But I think the fourth one seems, and he said that's the one that most people think of. Is that what he said?
Type 4?
Yeah, type 3.
Oh, type 3. I think, yeah, that's probably the most
Yeah.
popularized one.
I think like the biggest question as like a non-science person is like, is there any possible way to access another multiverse?
Only mathematically at this point.
Yeah, there's no
Yeah,
there's yeah.
yeah. I mean,
Right.
we can maybe create a miniature black hole in the lab eventually. I mean, there might be miniature black holes all around us even right now. Some actual physicists who aren't, just not just making up stuff, they suggest that everything a proton is actually a black hole.
Mm.
Oh, no way.
They do the volume inside of a proton. Again, that would be some of the other dimensions that are in there. And they get numbers that match up with the entire size and volume of the known universe and the mass and the energy. They can all be matched inside the actual proton.
Hmm.
So that's probably as realistic as we can get at the
Is
moment.
is is
Otherwise,
there
it's imagination.
is there any danger to that? To the
Oh, well,
fabric of
actually, no, that's a good question. When CERN was built, and when it was upgraded, the Large Particle Collider in Switzerland, it was
Mhm.
built back in the late 50s, upgraded in 1976, and then it was upgraded again to discover the Higgs boson. It had an actual lawsuit given by real scientists, no, not just someone off the street that was worried that they would create these mini black holes and the whole Earth would fall into it. So of course they got over the lawsuit, and it's been working for many years, and the whole Earth hasn't fallen into this little black hole. They do create a lot of energy. It's 14 trillion electron volts, but it's over a tiny amount of space, and there's more energy in the cosmic rays coming in all the time than what CERN creates over that tiny amount of space.
Mm.
But no, there's no danger at all. Yeah.
Mm. Yeah, I do feel like the many worlds interpretation is um, probably the more commonly kind of depicted in a lot of places. And that one really has, it kind of goes back to Schrodinger's cat and
Yeah.
kind of the uncertainties principle and everything like that.
Right.
And I guess it goes to kind of where every quantum event is almost like a branch point, um,
Yeah.
which in some ways,
Mhm.
like the Everything Everywhere All at Once movie, like it does seem like a mix of those two because it talks about how you access all at once, and shows kind of the different pathways one individual in another parallel universe can take.
Yeah, Schrodinger's cat is really interesting. I think maybe if some of our listeners aren't familiar with that, it gets into two basic principles of quantum mechanics, which is entanglement and superposition.
Mm-hmm.
So basically, there's a cat in a box, and
why did he use a cat?
A cat in a box. And there's a more advanced one called Wigner's friend. It's two people that see this or see some other event, and then they don't know if the event happened when the people saw it or when they transmitted that information to another level. So it's like Schrodinger's cat taken to one level further up. But the cat's interesting because it's a random event. If it triggers some radioactive thing inside the box, so when you open it, will the cat be alive or will it be dead? It'll be one or the other. Yeah. So it's almost like the Copenhagen interpretation of it in a sense. But it does go to superposition, which actually goes to the basis of how quantum computers work. And they do already work. You have the super cool stuff to almost absolute zero. And what I just found out recently in this research, that is actually, quantum computers wouldn't work without multiverses, without other similar quantum things happening outside of our own universes to make those states possible for us to use to basically do everything at once. That's what a quantum computer does. Instead of a binary bit, like if you shake somebody's hand, so the quantum bit, it's called a qubit, would have all the states. Like if you have 1,000 hands to shake, it would do all 1,000 at once. And what's even more interesting, a lot of our processes, biological, within our brain and our biology, to get certain energy transferred within the cell at that level, is doing this right now all the time. And we don't even know how it works, but it's strictly a quantum event. And every single one of us, this is happening right now. All these things are happening at once, and that is just linked to other universes in a sense. So I don't know if scientists would use this as a proof, but I would use the superposition part as a proof of other universes right here manifest in this universe, which is really already a mixture of other universes in some sense to begin with.
Yeah, I mean that goes back to, I think the first experiment was the double slit experiment that kind of that was talking about that superposition and how could that electron come out in two places versus
you can even send one single electron and it'll still turn into a wave. So there's no classical Newtonian way to explain that. It's the quantum effect.
And so that kind of goes back to, I think when you were going through some of the levels, you had talked about one of them where it was like the wave collapsing. Yeah. And that's kind of what we're referring to, right?
Yeah, I mean it kind of makes sense. That's called the Copenhagen. Niels Bohr, he came up with that. There's many different ways. There's probably 4 basic ways to interpret that experiment. The experiment was done over 100 years ago, before we even knew about quantum mechanics. But now we have other ways to interpret it. There's probably more than 4. But so that one is almost a little older now. Some of the other ones are actually more interesting and lead to more possibilities.
Yeah. So, Bernie, do you feel like, none of this is, I guess it sounds like when you were saying, with quantum computing, we would be able to possibly see some of this in action. But as of right now, do you feel like any one of those levels that Tegmark was describing could be more possible than another?
Yeah, good question. I think they're all possible in some sense. I mean, there's something called quantum supremacy, which they thought they reached, just proving a quantum computer is actually faster than a regular one. The big supercomputers can do now over 1 trillion calculations per second. But it hasn't really been proven, and it's a little bit, disputed and so on. Yeah. And even then it'd be very limited. But eventually, I mean, it may still be a few more years. They will obviously be more useful than regular computers. We won't all have our own desk one because you need coils and, bring stuff down to absolute zero and all that. So we can share info from a quantum computer and then get the benefits of it. So, so they're going to be really good for code breaking and stuff. But if our own cells are doing some of this right now, it's just more of a matter of us figuring out what it is that they're doing and how, and if we can recreate some of this.
Yeah. I guess I don't know. What do you think though? Because when I see like those two interpretations in those movies on Multiverse, one is like, hey, there's multiple versions of you who have the timeline is exactly the same or somehow, and you're just, you have taken on a different life path. And even the Spider-Man one where it's like somebody else that is you, like living your life
Mhm.
in some ways.
Mhm.
I don't know that, like, I feel like there's so much variation. Could it really be all that similar in another universe? Like, it's almost suggesting that in a parallel world, all of the conditions would ultimately collapse into like the same thing, you know? I don't know. What do you think?
Uh, Big question.
I will say that a lot of places when you like learn about the multiverse and people try to describe it, they have said that the human mind is not equipped to think about these
Yeah.
concepts.
Well, in a way, no, but in a way, yes, because I've heard from like neuroscientists, people like Heather Berlin that we've talked about before. The mind can actually think in 17 dimensions. It's more complex than an entire galaxy.
What does that mean, Bernie? What does that mean that we can think in 17 dimensions?
Well, I mean, that's a good question. And maybe again, it may be things going on that we haven't figured out. Like
Yeah,
I just recently
like
heard about quantum
subconsciously
effects
we
inside
have
the
a
cell.
part of our mind that is thinking about something else and we're not even aware
Oh,
of it.
not even a thing per se. It's more the process. In some sense, I think we do have access to this right now. Obviously, we have access to just the thought in creating a movie like that.
Mhm.
You know, anything that we can think of is possible, and we can bring it out through computers and screens and everything else.
Mhm.
It's just that we haven't tapped into much of what our own minds can do yet. Yeah.
Yeah. So, okay. I feel like with the multiverse, there's this weird boundary between scientific theory and like philosophical notion. So let's end on kind of a little more positive note here. For both of you, do you, let's say without kind of knowing true or not true, would you want there to be a multiverse in that is kind of, you know, what those movies describe in one way or another?
I mean, for me, I think it's kind of comforting in a way to know to feel like there would be another me out there, you know, living something completely different, you know.
Yeah.
Maybe something I might have missed in this life, or maybe, you know, the possibilities in that is just really.
What if they're like a terrible person?
I mean, there's another universe where that isn't true, right?
Yeah, and you would
Yeah.
never actually know the difference.
In the grand calculus of the multiverse, one baddies like.
What about you, Bernie? Would you
Yeah,
actually
no, I
want
definitely
there?
think it's
Yeah.
there. I mean, I even asked my students at the last lab we do, it's called Hubble's Law, the rate of expansion of the universe. I asked them if they think there's a multiverse, saying that about half the scientists and astronomers think there is and half think there isn't, but it's still totally subjective. And then I tell them not to just say yes or no, but to give me a reason and how it would affect them, because it would. I think it gives us huge numbers of possibilities. You know, everything kind of opens up, as Dylan said, that another version. In some sense, there's 8 billion versions of us right now on the earth right now. You don't really even have to get to some other multiverse to see that exhibiting, you know, all the different traits we may or may not have had at some point or in some future or past life and all the other interesting things. So all these versions are already here, but we can kind of access them, and it does make a big difference, I think, if there is any of those levels or even more. There could be 10 or 20 more levels of multiverses. So it is important, and it gives us the possibilities and potentials, and they're here right now. We don't have to wait.
It's wow, that feels so optimistic, Bernie.
Yeah. Well, it is. I mean,
it feels
you know,
like we can do anything we want in another world.
Yeah.
Yeah, no, we can. I mean, rockets. You know, all the possibilities, all the mathematics for rockets was here 100,000 years ago. You know, Neanderthals and cavemen, they just didn't have any of the techniques to do it. And just imagine what will be possible 200 years from now, as far as rockets or anything else, hyperspace, multiverse, all this stuff. Yeah.
Well, on that note of positivity, Dylan, thank you so much for joining us.
Thanks for having me.
Thank you for making music for our show.
Of course.
For our ending and our opening theme. And with that, you have been listening to Scientifically Speaking here on WMPG with myself, Bernie, and Dylan. Stay tuned for Something for the Weekend with Anella. And for my favorite nerds, just a reminder to vaccinate, to mitigate, and then we can all congregate.